So tonight's lesson is going to be about points, lines, and planes. Okay, this should be a review. You should have learned most of this in 7th grade. We're just going to go over and make sure you know how to write these things, you know what they look like, and you're prepared to use them for the rest of the year in geometry. We're going to start with the simplest of these three. The simplest out of all of these is a point. So I'm going to put a single point here. This will be point A. Hopefully you remember that when you write a point, you use a capital letter. Over here on the side, I'm going to list out each thing when we draw it and we add it to our picture here. So for now, we have just a point. This will be point A. So I'm going to add another point to my drawing. This is going to be point B. So if I want to list multiple points, I just put a comma and list the next one. So I have point A and point B. Now, through these 2 points, I can draw a line. That didn't go very well. I'm going to use a straight line tool, part of my software here. You may want to use a ruler, straight edge, your ID card, driver's license if you have one of those, but anything straight will make a nice straight line for you. And you know, since it's a line, it's got to have the arrows on both ends. That means it goes on in both directions forever. So if I want to list out the lines that I've made here, well, hopefully you remember that to name a line, you have to use any 2 points, not 3 points, not 4 points, not 5 points, 2 points, only 2. So this is line A, B. It could also be line B, A. The order doesn't matter. Either order is fine. Now, let's say that we have a point in the middle here. This will be point C. This is also line AC. This is also line CB. Okay? Any combination of any 2 of these is perfectly fine for naming this line. What we don't want to see, and what happens all the time, is we see this. Okay? Line ACB. Well, if I see this, you're going to see this, because this is not correct. Okay, so you don't want to do that. Don't use 3 letters, just use 2. Any 2 on the line will do. Okay, the next thing that we're going to talk about, I'm going to add a little point here. So here's point D, and I'm going to connect it to point E. Okay, so these 2 points are connected. They're both on the end of this little piece of a line that I've created. And that little piece of a line, hopefully you'll remember, is called a segment. Okay, segment. A segment is named using both of the endpoints in either order. Doesn't matter, DE or ED. Now, when you're naming lines and segments, what you put on top matters. If you put this and you meant this, you're going to be wrong. Okay, it matters. The details matter in geometry and in math. So make sure that you label it right. If it's a segment, it gets a little bar. If it's a line, it gets a little line. Okay, the next thing that we're going to talk about, the next thing we can do with points, lines, and planes, by drawing some points here, I'm going to put a point F. And I'm going to draw a half of a line off of it. Put another point here, FG. Okay, this, hopefully you'll remember, is called array. An array is very specific in how it has to be named. When you name array, you have to name the endpoint first. So this is array FG. Okay? Now do not write this on your paper unless you really want to. You don't need it. Okay? This is what we see a lot of in geometry. This is not correct. You have to use the endpoint as the first letter. Okay? So do not think that you can swap the letters around on array. On a segment, swap them around, no problem. On a line, swap them around, no problem. Okay? Now we're looking at this ray here. We have ray FG. we could easily, off the back side of this, draw a ray that goes in the opposite direction, right? We'll put a letter out here, A, B, F, G, H. There'll be an H here. This ray starts right here and goes out this way. So this is ray F, H. Get rid of this one. Don't do this. Okay. When you have two rays connected with a common endpoint like this, and they form a line, okay, they have to form a line. They're called opposite rays. Opposite rays. Okay, now if they look like this, don't write this. Okay, if they look like this, common endpoint, right? Two rays, these are not opposite rays. Okay, so just because there's two rays doesn't make them opposite rays. They have to go in opposite directions and they have to form a line. And so those are opposite rays. Now, remember when you're naming the ray, you always start at the endpoint. Okay? H and G, these are not endpoints. These are just points that are on these rays. Now, D is an endpoint, and E is an endpoint. So an endpoint is the point that's on the end of a segment or array. It doesn't necessarily mean it's the end as in it's where it finishes or stops. It just means it's on one of the ends. So just because somebody says endpoint doesn't mean you have to put it on the far end of something. It's just a name for it. Now, all of these things, these points, these lines, segments, rays, all these things we've drawn here, okay, they're all contained within something. Okay. They're all contained in a plane. So I've got this plane here, and the way we draw a plane is to draw a big parallelogram. Okay, and everything that we draw inside the plane is considered to be in the plane. Now, the way you'll see planes written, there's several ways. A plane can be named using any three non-collinear points. Well, what does non-collinear mean? Hopefully, using your context clues, non-collinear means not collinear, which means not in the same line. So I'm going to pick 3 points, A, C, and D. Now you might say, wait a minute, A and C are in the same line. They are, but I need to pick 3 points that are not on the same line. So as long as there's 3 of them, and as long as all 3 are not on the same line, I'm good. So this is plane A, C, D. Now I could write it in any order, right? DCA, ABC, DAC, doesn't matter. I also could have gone through here and used ACE, or BDG, or FHB. Any combination of 3 non-collinear points. And another way to write plane, instead of writing the word plane, is to draw a plane symbol, which is just a parallelogram. Okay, draw your little parallelogram, and you can use the exact same letters. Okay, there's a third way to write a plane, and you'll see it a lot. Right, in the top corner of the plane sometimes, or maybe in the bottom corner down here, you'll see a capital cursive letter. Now I did cursive 25 years ago, so cut me some slack. That's a cursive R, and we will call it plane R. Okay, so all 3 of these name this plane right here. So that's 3 ways to name a plane. Now I mentioned a minute ago about collinear. Okay, collinear means on the same line. So if we look at our picture that we've drawn here, and we look at points A, C, and B, well, we can say that A, C, and B are collinear, right? Because these 3 points are on the same line together. A, C, and D are not collinear. Also, we could say H, F, G, collinear. We could say D and E are collinear. Even though there's not a line there, I could draw one, right? I could draw a line that goes through D, through E, no problem. I could not draw a line that goes through C, D, and F. See how that works? I could go from C to D, no problem. Make a line, everybody's happy. But I can't make that same line turn and go through F, because the line has to be straight. So collinear just means that they're in the same line together. Right? What do you think coplanar means? Okay, coplanar means that they're in the same plane. So if we, and now this is a big plane, we got a lot of points in there, it might be a lot of writing, so I'm going to write a smaller plane down here. Say this is a little plane in your problem, or your homework. So it's plane with a W, an X, a Y, a Z. Okay, and I'm going to call this plane, what's a good cursive letter that I can draw? I don't think I can draw it. Plane F. Okay, so here's an F in the plane. Now, you might have a problem that says, name any points that are coplanar. So, look at our points, and we have W, X, and Z are coplanar. Okay? So W, X, and Z are coplanar. Y, right here, is not coplanar. And another big mistake that people make is they put this F in here with these points just because it's a letter that's in the plane. This is not one of the points. Okay, this is plane F. We can call this plane F, or we could call it plane W, X, Z. Okay, the F is the name of the plane. It's not a point. All right, we're almost done. I've got 5 things that you need to know now. These are 5 postulates. A postulate is basically a thing that you need to know. Okay, so if you hear the word postulate, you need to make sure that you know whatever comes after it. So the first postulate says that through any 2 points, so I'm going to take these 2 points, A and C. Through any 2 points, there exists exactly one line. And what that means is if I try to draw a line that goes through point A and through point C, well, it's going to be the same line I've already got. It's going to be the green one. You see how I can't make a line that goes through A and through C, but isn't the green one I already made. So hopefully that makes sense to you. Through any 2 points, there's exactly one line. Okay. The next postulate that you need to know is that through any 3 non-collinear points, so 3 non-collinear points, how about A, C, and D, there's exactly one plane that contains them, and that should make sense to you. If you make 3 dots on a piece of paper, like this, 1, 2, 3, okay? Well, they're on that piece of paper, right? That piece of paper is your plane, okay? Now, could you take those 3 dots that you drew on your paper right in front of you and take another piece of paper and make those 3 dots also be on that piece of paper while they're still on the same piece of paper you drew them on? The answer, of course, is no, because through any 3 points, there exists exactly one plane. All right, the next postulate that you need to know is that if 2 points are contained within a plane, so point A and point C. In fact, I'm just going to go over here and draw you another little plane here to illustrate this point even better. If 2 points are contained within a plane, then the line that contains those points lies in the plane. Now that may seem like a Captain Obvious statement to you, but it matters. So you need to make sure that you know it. If there are 2 points contained in a plane, then the line that passes through those points is also contained in that plane. Make sure you know it. All right, we've got 2 more to go. The fourth postulate says that 2 lines intersect. So 2 lines intersect. So if that happens, then they intersect in exactly 1 point. Okay, if 2 lines intersect, then they intersect in exactly 1 point. Last postulate says that if 2 planes intersect, now this is a little harder to draw. Okay, this is not the beginner level drawing. In fact, I'm going to kind of cheat when I draw it. But if two planes intersect, now you can practice drawing it, see if you can come up with something really cool, bring it to class. I'd like to see it. But what I'm going to do is think of my planes as walls. So if you look in the room that you're in right now, you'll probably see at least two walls coming together somewhere. Right? We're going to pretend that those two walls, so here's a wall, here's a wall. Well, they intersect, right? And they intersect right here. This is where they intersect. Now, you have to imagine that your walls go up forever and down forever. Right? They extend forever in all directions. That's what a plane is. So our intersection would extend forever in all directions. So the intersection of two planes, or if two planes intersect, then they intersect in exactly one line. So those are your 5 postulates. Make sure that you know them. Also make sure that you can identify, draw, and name all of the things that we discussed here in this video.